All right, question number 3, we also want to find the domain of the function. So we are given 3x minus 4 over 3x minus 9. It's already in linear factors. I can see that there's nothing in common that we would divide out. It would have to be the whole expression. So I would just take the bottom and set it equal to 0. So I will say domain 3x minus 9 cannot equal 0 because we can't divide by 0. We'll add 9 to both sides. So we'll get that 3x cannot equal positive 9. And then we would need to divide by 3. And then we would get that x cannot equal to 3. So 3 would not be in our domain. And if I looked at a number line to write this in interval notation, I would be looking at negative infinity to positive and removing the number 3. So 3 would be removed. That would give us the interval negative infinity to positive 3 in connection or union with 3 to positive infinity. Make sure I type that in correctly. Negative infinity to 3, union 3 to infinity. Double check that there are no errors. Okay, so I wrote minus and it should be a plus 9, so that is my error there. This should be a plus, so when I move this over it'll be a negative, and so that'll be a negative 3. So I am sorry for writing that down incorrectly. R3 should be negative. Just be careful. That is my biggest error, is not copying down the original problem correctly. Number 4, it has 4 parts. Okay, so it says we want to list all the asymptotes, and then we're going to graph the function. So first it wants to know vertical asymptote. So the vertical asymptote also come from the denominator like we've done before. So we have a function r of x. They'll change these letters. It doesn't mean anything, just a letter. All right, so again, we'll be focusing on the denominator. This will factor into linear factors of x plus 5 and x minus 5 by difference of squares. Okay, you got 2 perfect squares, so you need to remember that setup. Again, we will be setting these equal to 0. So I'm going to take the x plus 5 and set it equal to 0, and the x minus 5 and set it equal to 0. This will give us x equals negative 5. This will give us x equals positive 5 when you move it over. So these will be our 2 vertical asymptotes. Whatever makes the denominator 0, so we'll get 2 of them, x equals 5 and x equals negative 5. So vertical asymptotes. And it tells you right here, use a comma to separate answers and type equations. So you cannot just type negative 5 and 5. You have to type x equals 5 and x equals negative 5. The order in which you type them does not matter, just so long as you get them both. All right, so now it wants to know, is there an oblique asymptote? So that happens when the degree of the top is exactly 1 more than the bottom. So in the overview beginning, we talked about oblique. Here's my example. The degree was x squared, the degree on the bottom was x, so that was exactly 1 more. That's not the case here. the degree on the bottom is bigger, so there will be no oblique asymptote. Horizontal asymptote, we check the degree of the top and the bottom. So when the degree on the bottom is bigger, we have our asymptote being 0. So remember, we had a 1 up here and a 2 on the bottom. So anytime the degree on the bottom is bigger, your horizontal asymptote is y equals 0. So it tells you right here, type an equation, so don't just put 0. Okay, so now that we have all of our asymptotes, we want to know which graph is correct. So if you were graphing this by hand, you can plug in and do a few points. So here's what we would have. I'm going to draw X and Y axis grid. Now what we would notice, and you won't see it on the graph, but there's an asymptote here. That is y equals 0. Okay, so the graph will not cross the x-axis. Then let's say that this is x equals 5. Let's say that this is x equals -5. There will be a line or imaginary line that the graph will not cross here as well. And then from there you can kind of plug in points and kind of see what they look like. You can graph it, but all we would do is kind of plug in numbers and find out what coordinate they would match in, and you can kind of get a rough estimate. So just say, for example, if I want to make a table of points, and let's say I wanted to plug in 0. So 0 would be here. I want to know what's going on at 0. So if I plug in a 0, this will be 4 over 25. And so when x is 0, I would be like very, very small portion of the way, like close to 1. Like if I was saying this was 1, it would be almost a fifth, okay, 1/5 of that line. And then I can plug in a few more examples, numbers, and see what happens to get close. But as I look at these and just try to eliminate some options, I can definitely get rid of A and D. They don't have the 2 vertical asymptotes, so it will give me either B or C. And based on the 1 point that I plugged in, which was 0, giving me this should be a negative, I'm sorry. 4 over 25 should be a negative. So instead of me drawing that point here, it should be on the negative side. Again, I kind of made an error. So that lets me know that the only one that has a portion of the graph between B and C in the negative side is C, which looks like our graph would give that shape. Okay, that's the one that matches or has a point there. And that's kind of what you would do if you were doing it by hand. You can do multiple points. I do want to show you also, if you have the calculator app, where did it go? Okay. So if you have the calculator app, we can also graph it and look somewhat similar. Look at their scale to make sure you get your graph to look at as close as possible to what they have. So what I'm going to do is I'm going to go to y equal. I'm going to clear out what they have here, and I'm going to graph this rational function. So I'm going to do 4 divided by, and then the denominator I'm going to put in parentheses to make sure it does it correctly. I'm going to do x squared minus 25. We're going to graph, and I'm going to change my window to match theirs. So you can kind of see just a general shape. Looks kind of like that. If I go to window and my x goes from -10 to 10, but the y goes from -2 to +2. So let's graph that and let's see if we get a better picture. Okay, and so that's how you kind of see exactly. You don't see the asymptotes, the dotted lines. They're imaginary. That's for our purpose to know that the graph will never cross those lines.